Many different engineering software tools are used in system development. SysML tools like Magic Draw or IBM Rational Rhapsody are appropriate for architecture modeling, while Simulink is used for system simulation. But problems arise when different team members develop inconsistent models. Syndeia, from the Greek for bringing things together, has a SysML Simulink interface supporting multiple use cases. For organizations beginning their conceptual design in SysML, the connectivity shown in an internal block or activity diagram can be transformed into a Simulink block structure. If the modeling begins on the Simulink side, it can be transformed into a congruent SysML model. These are not one-time export-import operations. In the model transform process, persistent connections are made at the model element level that allow the models to be compared and updated bidirectionally as the development process proceeds. SysML and Simulink serve different purposes and follow different modeling rules. Not all SysML model information is transferred to Simulink during model transformation, and vice versa. What are common between them are blocks, connectors, and ports, and these are what Syndeia keeps connected. Let's look at an example of an unmanned aerial vehicle in SysML. At the top level, the aircraft platform and payload are joined at a number of interfaces. Both parts have their own internal structure. For the aircraft platform, the SysML internal block diagram looks like this, including another level of structure inside the avionics block. And the payload diagram shows 3 connections each to 3 payload components. We will launch Syndeia from the Magic Draw GUI and drag the top-level UAV block from the SysML model on the left into an empty folder on my local file system on the right. I need to confirm the type of model transform needed to a Simulink model rather than, for example, a CAD assembly. After a short time, that empty folder now contains multiple Simulink files. I can open the Simulink model right from the Syndeia dashboard, or even from the SysML diagram, by right-clicking and choosing Open. My license of Simulink opens, and I can see the Simulink model I've just created. It does not carry over the layout from the SysML diagrams, but with a little rearrangement, I can easily see that the basic structure has been reproduced, not just for the UAV block, but for the aircraft platform, avionics, and payload blocks in the multi-level structure. Looking at the Connection Summary tab on the Syndeia dashboard, I can see that there are 17 connections being maintained by Syndeia between SysML and Simulink models. I can use those connections to compare and sync model structures. I will start by changing the SysML model. The radar payload component has been deleted, along with the 3 internal connections. Going back to the Syndeia dashboard, I find the payload part and select Compare SysML and target. The red rows in the Results Comparison tab show that the radar block and 3 connections are now missing on the SysML side. In order to push those changes to Simulink, I will choose the same payload connection and choose Sync SysML to Target. Reopening the payload diagram from the Syndeia dashboard, I can now see that the radar block and the internal connectors are gone. The same process works in reverse. We'll drag the UAV Simulink block into an empty package in SysML, but we'll choose an activity model rather than a structural internal block diagram for the reverse transformation. When we create an activity diagram, for the top-level UAV activity, we can see the aircraft platform and payload interfaces shown in a different format. The Syndeia Simulink interface has many other features. Standard Simulink primitive function blocks can be modeled in SysML, allowing partially or fully executable Simulink models to be generated directly. In a separate video, we describe the similar capabilities available for stateflow state machines and transitions. Contact us at info@intercax.com to learn more.